In this video, I'll show you how to use Geogebra to find critical values for any of your hypothesis, tests, or confidence intervals. So first, let's go to geogebra.org/classic#probability. We'll go to the distribution tab and choose the normal distribution. So first, we're going to keep the mean as 0 and the standard deviation of 1. And we want to work with these buttons that put left or right tails instead of area in the middle, because GeoGebra doesn't work quite like we'd like it to. So I'm going to work with area in the right tail. First of all, a 90% confidence interval means that 90% of your area is in the middle of the distribution and centered. So we have to do a little bit of subtraction. If 90% is in the middle of the distribution and there's 100% total, that means there's 10% left over for the tails. And because our distribution is symmetric, half of 10 is 5. 5% area goes in each tail. So I'm going to change this lower right box to say 0.05, push enter. And what's given to me in the middle part of this lower line of math is my critical value. So 1.6449. So right here, at the triangle, that is my critical value. It cuts off 5% area in the upper tail from the other 95%. Now, 95%, wasn't I just computing a 90% confidence interval? Remember that we kind of pretend that there's 5% in the lower tail, meaning 90% is there in the middle. Let's say we want to compute a 95% confidence interval. We do the same sort of little bit of subtraction. 95 goes in the middle, subtract that from 1, which means 5% is for the tails. So both tails have to share 5%. Half of 5% is 2.5%. So as a decimal, 2.5% is 0.025. Now I'm choosing to work on the right side here because if I worked on the left side, my critical values would give me a positive would give me a negative answer, and critical values aren't negative. You can come up with a negative answer, but you need to drop the negative because the plus and minus part of your confidence interval formula is accounting for there's a cutoff on the positive side, there's a cutoff on the negative side. So that's taken care of for you. You just need the whole number part to go into your confidence interval formula. So 2.5% on the left and 2.5% on the right leave 95% in the middle. So the cutoffs for that 95% are 1.96 and then also negative 1.96 on the other side. So for a 95% confidence interval, 1.96 is your critical value. Let's talk about another special case, and it is with quartiles. Let's say you want to make a 50% confidence interval. That means that 50% of the area would be in the middle of the distribution. This is kind of like saying, where are your quartiles? So 50% in the middle puts 25% to the right and 25% to the left. So if I change my area in the right tail to be 0.25, this number right here at this triangle cutoff mark is 0.6745. That means this is my third quartile. Why is it the third? Well, we always start on the left side. So if you count up 25% of your area to about here at negative 0.6745, that's quartile 1. Then you go another 25% of your data and you land at 0, so that's quartile 2. You count up another 25% of your area right here. This is quartile 3. And then you go all the way to the end, and that's quartile 4. And actually, there's a quartile 0 as well. It's the minimum. So if you put 50% area in the middle, then your critical values for a 50% confidence interval would be 0.6745, or sometimes people just round it to 0.67. So there you go, a short introduction on how to find critical values with the normal distribution with GeoGebra.